So I started here in UCL in September of 1970 and graduated in June of 1973. I did my BSc honors in chemical engineering, and after that, I went to the United States to do my PhD in chemical engineering at the California Institute of Technology. I graduated from Caltech in 1978, worked as a postdoctoral research fellow for about a year and a half, and in 1979 moved to Atlanta, Georgia, where I started as assistant professor of chemical engineering at the Georgia Institute of Technology, worked there for 42 years, and retired in June of 2020 in the midst of the COVID pandemic. So when I started here at UCL, like I said, came in September. I think our lectures started in early first week in October, if I'm not mistaken. And at that time, there was 35 students in our class, and we got divided amongst faculty. And you were given a tutor, and John was my tutor. And it turned out John had done his undergraduate and PhD here at UCL, and had just started as a staff member the year before. I remember his small corner office and going there and sitting down. There was 4 of us that would sit and we would talk to him. Our tutorials were not formal. We would meet with him at least once a week, but if we were having trouble with a certain set of materials in a course, he would tell us who to go talk with if he could help. And we had a very pleasant and open relationship. I left here in '73. Those days there was no email. Obviously, when in the United States, I was not good at writing letters or anything like that. I lost touch with him. Saw that he had put a testimonial on the website, so I wrote to the the administrator here and said, can you give me Dr. Garside's email? And we connected. And actually, we got together for dinner last night. And that was fun, 50 years down the road, meeting someone. He hasn't changed very much. He's got a beard now, and obviously he's great. I've got older. But I still have very fond memories of him. And a lot of the other staff, Professor Rowe and Professor Mullen, who were the 2 professors here. Department was small. I think a total of 100 to 120 students between the 3 years. Like I said, our class was 35. And I think between the 3 classes we had, there were only 2 female students. So very different today. And not multinational as it is today. You have a lot of students from Europe. We had, there was, out of the 35, there was, I think, either 5 or 7 of us, but we all came from Commonwealth countries. There were no European students, no this thing, a very different mixture. And even all the staff were mainly British staff. With respect to interactions with industry, I had done that starting at a very young age. When I was at UCL in my second year, between my second and third year, that summer I spent 6 weeks at the Shell refinery in Stanlow, looking at distillation columns. So I had an experience there, look to see how chemical engineering that we learned in the classroom was applied. And then when I started at Georgia Tech, I got the opportunity to spend 3 months one summer at DuPont at their main research facility in Delaware. And that was also very eye-opening for me because as an academic, to see how industrial research was done. And that sort of stayed with my career even in biomedical engineering. In all my research, I work very closely with the industry that works in the cardiovascular medical devices. And I think that's very important for any one of us who are in academia to have a good understanding of how what we teach our students and how our research is applied to industry, because that otherwise it becomes so fundamental, which is important, but it needs to be applied and translated to practice. Chemical engineering has changed quite a bit. in terms of areas in which chemical engineering has got involved in. And actually, my research went very much in a very different direction than what traditional chemical engineering was. In 1973, when I went to Caltech, I was thinking of going into environmental science and air pollution, because that was a big area of research there in Caltech in the chemical engineering department. However, there was a professor there who was working in the area of biomedical engineering, and he was interested in blood flow in the heart and large vessels. And I found that to be kind of very intriguing, that there was an application of engineering to medicine. And actually, it's using fundamental fluid mechanics, which as a chemical engineer, we looked at in our program here. We did some research. And so my area of research has been in blood flow, cardiovascular fluid mechanics, as we call it, biomedical engineering. And over a period of my time at Georgia Tech, as I said, I started in chemical engineering and was in that department for almost 20 years. In 1997, a biomedical engineering department was created at Georgia Tech, and I was the second founding member of the department. So I moved my academic position to biomedical engineering, even though I had a secondary appointment in chemical engineering. One area I'm extremely proud of and very passionate about is working with small children who are born with defects in their heart. These are called congenital abnormalities, and they have to be corrected within a few weeks to a few years after the child is born. And in order to do that, today we use a paradigm of imaging, using MRI or X-ray imaging to understand the structure of the child's heart and to come up with corrective procedures that would help the surgeon do optimal surgery on these children. And that's an area that I'm extremely proud of, and the contributions we've made to that field, and have had the opportunity of working with some of the leading, what we call pediatric heart surgeons across the world. So as a chemical engineer, I think one of the things that we learn, it's not the details of what you learn from a book or the lecture. It's sort of the thinking process, the analytical, mathematical processes that we use to understand a problem, to define a problem, and then find what's the best solution for it. And I think chemical engineering, even today, I think is probably the best engineering discipline that trains us to do that. I have very good friends and obvious colleagues in electrical and mechanical, but their focuses tend to be narrower than chemical engineering. Chemical engineering is broader and has been, and I think that still, stands out, and I think we still educate our students that way. Now, biomedical engineering is trying to do that, but the challenges that biomedical engineering has is that biomedical engineering translates across a lot of engineering disciplines. It translates across chemical engineering, mechanical engineering, electrical engineering, and it's hard to educate someone in a 4-year period with all those skills. So that's but chemical engineering has done that very well for over 100 years, and so I think that's the one skill I felt I took from UCL and have used throughout my career. So my advice that I give my students, both undergraduate students, graduate students, my postdoctoral trainees, is I say, always keep an open mind. Don't say, I'm going to do this, and then shut yourself off from whatever else around you. Because when I look back on my career and things I've done, there were opportunities that I hadn't thought about. It would happen in a discussion. Like I said, I went to Caltech to do air pollution research. And if I had done that, I'd know where I'd be today, obviously in a very different place. And when this professor got up and started talking about blood flow and trying to use engineering to solve that got my interest It wasn't something I knew about. Similarly, a lot of the research areas that I've got into have been through a conversation or picking something up in a newspaper. So yes, we have goals in our life, but that doesn't mean you want to keep what we call blinders on without looking outside. And also that not to be afraid of trying something new. It's always easier to keep doing the exact same things you're doing because you feel very comfortable. I always say, think outside the box and take a chance with new things. Otherwise, and that's what gives you the fun and excitement in things.